Quick stop, external and internal IP addresses. The production machine, or production as we call it, is simply a remote physical computer located at our hosting provider. That machine has a unique identifier among all computers on the Internet. That identifier is called an IP address, or more precisely, an external IP address. The format of the IP address: you can find the external IP of any website using the command ping. Let's find the external IP of sharelane.com. In addition to an external IP address, there is an internal IP address. The difference between an external IP address and an internal IP address is that an external IP address must be unique among all computers on the Internet. An external IP address is like the address of an apartment. It must be unique among all apartments in the world, otherwise mail cannot be sent there. An internal IP address must be unique only among all computers on an intranet. An internal IP address is like the conference room within a company. It must have a unique name among all other conference rooms within the company. Software builds. Now, after we have all the application's files checked into CVS, we have another task. We need to have the files from the CVS available in our test environment, main.sharelane.com. In order to do this, we need a two-step process. Step 1. From CVS, check out all application files for a specific release. In other words, we need to reflect the latest CVS content for a specific release. This reflection is called a build. Step 2. Transfer those files to the corresponding directories of main.sharelane.com environment for HTML and JS files, for images, for application core or Python files. Let's elaborate on step 1. Here is the definition for the term build. A build is a subversion of the specific release. Example, let's say that our coming release is 4.0 and our application consists of only two files, index.html and register.py. In CVS, we have version 4.11 of index.html and 4.23 of register.py. So the package that consists of version 4.11 of index.html and 4.23 of register.py is a build. But what if Billy changes register.py and checks it into CVS so we have version 4.24 of register.py? In that case, the CVS image for 4.0 will be different, and thus next build, which is subversion of 4.0, will be different from the previous one. Builds are created and pushed to a target environment. For example, to main.sharelane.com by a special build script that's written by the release engineer to automate his job. By the way, a release engineer, RE in short, is a software professional who builds and maintains release infrastructure, including version control, and handles things related to technical release matters, for example, pushing a new release to production. After a code freeze, a build script is often added to cron, the task scheduler on a Linux system, to create and push builds in equal intervals of time, for example, every 3 hours. Let's see the build schedule that we adopted at Sharelane. Test portal, release engineering, build schedule. The purpose of creating new builds over and over again is to make a modified application version available for testers. Example, let's say that you've found a bug during your testing on main.sharelane.com. After you filed that bug into the bug tracking system, the developer fixes it and checks that code into the CVS. The build script picks up that new code as part of the new build and pushes that build on main.sharelane.com, replacing the previous build. Now you can verify if the fix is good or not. Here are several things to remember about scheduled builds. Let's say we have the build script creating and pushing a new build to the test environment every 3 hours. 12, 15, etc., and it takes 15 minutes or less to run a build script from start to finish. There is no sense in doing testing from 12 to 12:15, from 15 to 15:15. because the build is being created and pushed. And when you do testing in the middle of the process, some files can belong to the previous build and some files can belong to the new one. If a programmer fixed your bug and checked in the fixed files into the CVS, you'll be able to verify the fix only after the new build is pushed to the testing environment. So, if the check-in took place at 16, then your fix will be available for verification only at 18:15. Thus, in many cases, it makes sense to launch the build script right when you need it. But if you do this, please make sure that the other testers know about it so you won't mess up their testing. In light of this, it's a good thing when each tester has his own testing environment. By the way, it's a good idea to ask your release engineer to create a build status page where you can see build ID, DB version, success status of build script run, time when latest build script run was complete. Let's see the ShareLane build status page. Test portal, release engineering, build status. In some companies, release engineers create a web interface to enable testers to push builds to test environments on demand. Build numbering starts with 1 for a concrete release and increments by 1 every time a new build is created. So after we created the first build for the minor release 23.1, the unique build identifier called build ID will be 23.1-1. After a new build is created, the build ID will be 23.1-2, and so on. By the way, as a rule, DB schema versioning is not linked to release versioning, so we don't start over at 1 with each new release like we do in the case of builds. We just increment each DB version by 1 every time the DB schema is changed. At ShareLane, we specify the DB version after / following the build ID. For example, in application version 23.1-2 / 78 is the DB version. Before you start testing or bug fix verification, make sure that you are testing the correct application version by checking the build ID and the DB version. As you already know, you should ask the release engineer to provide you with an interface to easily identify the application version. Using Python, Billy wrote the build script and added it to cron scheduler, so we have a new build being pushed to main.sharelane.com every 3 hours. The HTML code of each web page of sharelane.com has the application version, so we just need to view the source of any web page to know the version of the whole application. No more guessing and miscommunication about application version. Releasing version 1.0 to production. Finally, the code is written, the testing is finished, and the bug fixes are made and verified. Acceptance testing is finished. At our Go, No-Go meeting, we decided that we are ready for our first major release 1.0. Hooray! Our first live application version will be 1.0-23/34. Here is what we must do to release 1.0. 1. Configure the production machine, for example, create needed directories. 2. Upload the SQL procedure to the production machine and run that procedure against the DB to create the DB schema with version 34. 3. Configure the build script to create the build on the production machine. 4. Run a build script to create a build on the production machine. The build script checks out from CVS the files of the application version that we are going to release and copies those files to the production machine. As our project evolves, our production environment will turn into tens of servers which will form our production pool. But for now, ladies and gentlemen, our first release of ShareLane.com is live. It's time for champagne, dancing on the CEO's desk, reconciliation, forgiveness, and the realization that all those sleepless nights in the office were worth it. Guess what? Users seem to like us. Our user base grows like crazy, and now we have hired more people, developers, PMs, testers, and customer support. Release 2.0 is out, and it's a disaster. After another 3 weeks of hard work, we release version 2.0, but once we poured the champagne to celebrate 2.0, our CS Nina bursts into the conference room and tells us that she's been getting tons of complaints from users because 2.0 is filled to the brim with bugs. Basically, we have two options. Push version 1.0 back to the prod, replacing buggy 2.0. That's called a rollback. Fix bugs in 2.0 and push patch release 2.1 to prod. It looks like the first option, rollback, is problematic because at ShareLane, nobody seems to remember the exact version of each file for the production version of 1.0. Our build script is primitive, and as we create each new build, we didn't save the association between the build ID and the file versions that belong to that build. But after brainstorming, we found the solution. We can recreate release version 1.0 by checking out from CVS the file versions dated right before 1.0 was released. By the way, association between the build ID and file versions can be created inside a special log file. This is a plain text file. Every time we have a new build, the build script appends the file with the detailed information about that build. Here is an example of file format. That is what the file might look like if we had only two files, register.py and checkout.py. Let's see our current build log. Test portal, release engineering, build log.txt. In the general sense, it's not easy to figure out if the second option, bug fix, is more or less attractive than the first one, roll back to the old version. But this time it was easy for us. The reason is we have to go for the second option. Why? Because we've just discovered that our DB procedures have not been checked into CVS, and nobody remembers the exact DB schema used for 1.0. So even if we get the files for 1.0, there is a big chance that they will be incompatible with the DB schema for 2.0, and thus we might get lots of bugs. Example, let's say that file register.py from release 1.0 queries table users that belongs to DB schema for 1.0, but if DB schema for 2.0 has the table renamed into customers, version of register.py for release 1.0 will not work. Here are the negative consequences that immediately come as a result of the failed release 2.0 and the decision to fix bugs for it. The programmers who fix the bugs for 2.0 don't work on 3.0. The programmers who don't fix the bugs for 2.0 cannot do a CVS check-in for 3.0 because it was decided to lock the CVS and allow only bug fixes for 2.0 to be checked in. The tester is spending his time verifying bug fixes for 2.0 instead of writing test cases for 3.0. Lesson recap. 1. An external IP address is unique within Internet. 2. An internal IP address is unique within intranet. 3. A software build is a reflection of the latest CVS content for a specific release. 4. A build is a subversion of a specific release. 5. Builds consist of specific files with specific versions. 6. Builds are pushed to the test environment either on schedule or on demand. 7. A release engineer is responsible for the release infrastructure and technical aspects of the release. 8. As a rule, DB schema versioning is not linked to release versioning, so we don't start over with one with each new release like we do in the case of builds. 9. Before you start testing or bug fix verification, make sure that you are testing the correct application version by checking the build ID and the DB version. 10. Cron is a scheduler program on Unix systems. 11. Build numbering starts with 1 for a concrete release and increments by 1 every time a new build is created. So after we created the first build for the minor release 23.1, the unique build identifier called build ID will be 23.1-1. After a new build is created, the build ID will be 23.1-2, and so on. 12. Several production machines are called a production pool. 13. Rollback is when we return production to the old version. For example, after disastrous release 2.0, we considered to push 1.0 code back to production. 14. With release 2.0, we encountered a situation where our users were unhappy and the whole ShareLane team had to drop their task to release a patch for 2.0 ASAP. This is a normal thing when we release buggy code to production. As you remember, the most expensive bug is the bug that we release to our users, and that's exactly what happened with release 2.0.